Welcome to our next lesson here. So we are working in Chapter 3, Lesson 2, Solving Equations by Using Addition and Subtraction. So today we're really going to focus on solving basic equations. And so talking about what we're actually going to learn in this lesson today, solving equations by using addition and solving equations by using subtraction. So we're going to be able to solve pretty basic equations using addition and subtraction. Some important vocabulary to keep in mind is the idea of an equivalent equation, the idea of solving an equation and what it means, and those are the basic ideas and lessons that we're going to be learning today. So solving using addition. So it says, suppose your school's boys soccer team has 15 members and the girls soccer team has 15 members. If each team adds 3 new players, the number of members on the boys team and the girls team would still be equal. And so what this is going to lead us into is the idea of equality, which is what an equation is, right? So if both teams had 15 members, we could represent it with this equation where we have 15 members for one team, 15 members for the other team, right? And both teams would have equal numbers of players. And that's kind of the basis of what an equation is, right? When two things have the same value. Now, if both teams added 3 new players, right? Which means 15, or to the 15 I had, if I added 3 here, and on this team I also added 3, right? That would tell me that now this team has 18 and this team has 18, which means that both teams still have an equal number of players. So even though the number of players on each team changed from 15 to 18, the number of players is still equal because both teams added the same number of players. So this is the idea of using the properties of equality, right? If you add the same thing to both sides, or if you add the same thing to both groups, those two things will still be equal. So this, again, exemplifies what the addition property of equality means. And basically, and I'm sure you've heard this before, is if you add something to one side of the equation and add the same thing to the other side of the equation will remain equal, right? That's the property of equality using addition. So this property of equality, right, this is our key concept. And basically it just says if the same number is added to each side of an equation, the resulting equation is still true, which we want to do. That's going to help us solve equations. So here's some examples here. So here I have 7 equals 7, which most people would tell me that's pretty easy. I know that 7 equals 7. And if I were to add 3 to both sides of the equation, the left side and the right side, both add 3, that means this, I know 7 plus 3 is 10. So this side would have 10 and this side would have 10. Again, leaving me with an equation that is still equal, right? Both the left and the right side are still equal. And illustrating the same thing here, I have 14 equals 14. Again, pretty hard to argue that. And if I were to add -6, as long as I did it to both the left side and the right side, it should maintain its property of equality. So 14 plus -6 is going to give me 8. And so I know that 8 equals 8, right? The left side of the equation has 8. The right side still has 8. So therefore, the equation is still equal. The property of equality maintains that it's true. All right. So if the same number is added to each side of the equation, the result of the equivalent equation, which are called equivalent equations, have the same solution. So what does that mean? It means that if an equation is equal and it is true, whatever the answer is to that equation, no matter how I change it, as long as I'm using the properties of equalities, the answer will always be the same. So let's illustrate this. So here I have t plus 3 equals 5, right? And if you look at that, a lot of people will be able to do that in their head without too much issue. And most people would probably tell me, well, the solution is going to be 2. That's easy. I know that 2 plus 3 equals 5. So I know t has to be 2. Now, just to prove the property of equality, what if I took that equation and I used my property of equality? What if I added 2 to both sides of the equation? Well, if I add 2 to both sides of the equation, I know that 3 plus 2 is going to give me 5 here. And 5 plus 2 is going to give me 7. right? So I have t plus 5 equals 7. So the property of equality would tell me that this equation, both sides will still be equal to each other. And if I think about solving this equation, again, you could probably do this in your head pretty easily. You could tell me that, oh, well, in order for this equation to be true, t would have to be also 2. So if you notice, the equation here, the solution was 2, and the equation here, the solution is 2. I did not actually change what the answer to the equation was, even though I added something to the equation, right? As long as I did it to both sides, the property of equality maintains that the solution will always be the same. So to solve an equation, this is what it's going to lead as kind of the main thing, is to solve an equation means that you're going to find the values or the value for the variable that makes the equation a true statement, right? And so in this equation, it was 2. And one way to do this is to isolate the variable, right? And so you get the variable all by itself is a term that gets used a lot, right? And so what we're going to do is we're going to use that property of equality to get the variable all by itself, all right? So let's look at an example. So here it says solve m minus 48 equals 29, then then check your solution. So if I look at this problem, first thing I'm going to do, first step that I do to any problem, I'm going to write down my problem. So I have m minus 48 equals 29, right? Write down the original equation. And then I'm going to go ahead and use my property of equality to isolate the variable, to get the variable by itself. So if I look over to where the variable is, I have m minus 48. So really, I want to get rid of subtracting 48. So the way to do that is I'm going to add 48. If I add 48, and as long as I do it to both sides, I will maintain my property of equality. And the reason why I added 48 is because I want to zero this value out right here. Because if I minus 48 and add 48, right? If you subtract 48 and add 48, those two things zero each other out. They become 0 pairs. So that would leave me with m. And on this side, 29 plus 48 gives me 77. And so now I know that m has to equal 77, right? So I use my properties of equality to isolate the variable, get the variable all by itself. And that would give me my solution. So, well, I should probably check my solution to make sure it actually works. So one nice thing about these types of problems is it's very easy to check your solution. So let's go ahead and do that. So 77 is our solution that we think is going to work. So I'm going to take my original equation. And if I say that m equals 77, then this value for m, if I substitute 77 in there, it should make the equation true. So I'm going to do that. So I substituted m with 77. And then, well, the question is 77 minus 48, does it actually equal 29? And the answer is yes. 77 minus 48 does in fact equal 29. So 29 equals 29. Both sides of the equation are equal. So the statement is true. So 77 is my solution. I was able to check that. All right. So let's look at another problem. So here, again, I'm going to solve by adding, right? Because we're working that we know that if you add the same thing to both sides, it uses the property of equality to keep the equation true. And we're going to use it to isolate the variable, right? We're going to solve the equation by isolating the variable. So here I have 21 plus q equals negative 18. So step 1, let's write down our original equation. And then now I have to figure out what step 2 is, which is I have to isolate this variable. So I want to get rid of this 21 here, a positive 21. Well, the way that I can zero it out, right, in order to get the variable all by itself to isolate it, I could add negative 21 because I know positive 21 plus negative 21 will make 0. So I want to zero that out. So I'm going to add negative 21 to both sides. All right. So when I do that, I know that positive 21 plus negative 21 will make 0. So I'll be left with q, which will isolate the variable. And then on the right side of the equation, negative 18 plus negative 21 will give me negative 39. Okay. So again, zeroed out the left side, got negative 39 on the right side. So now I have my solution, q equals negative 39. So now I'm going to check it. So if I check it, I'm going to write down the original equation. And I said that q was equal to negative 39. So I'm going to substitute negative 39 in for q there. Right? So I replace q with negative 39. And then the question is 21 plus negative 39, does it equal negative 18? Because if it is the answer, it should be equal. And if we do the math, it does give us negative 18. So both sides give us negative 18. So that means our equation is true when we use q equals negative 39 as our solution. So that's our answer. Now, one thing you might say is, well, here I added negative 21. Couldn't I have just subtracted 21 instead? And the answer is true, which kind of brings us up to our next idea. If there's a property of addition property of equality, is there a subtraction property of equality? And the answer is yes. So that's what we're going to talk about next. We're going to learn about solving using subtraction. So we've done some addition, now we're going to use some subtraction. So again, similar to the addition property of equality, we're going to use the subtraction property of equality. So again, our second key concept here, using that property, right? And basically it means that if you subtract the same number from both sides of an equation, it will still keep the equation true. So again, here I have an example, 17 equals 17. That one's pretty easy for people to see as something that's true. Well, what happens if I subtract 9 from each side? If I subtract 9 from each side, well, that gives me 8 equals 8. It's still true, okay? What about, well, 3 equals 3. What if I subtract 8 from each side? Well, if I do that, that gives me negative 5 equals negative 5. Both sides of the equation are true. Again, this just illustrates the subtraction property of equality. If you subtract the same thing to both sides, the equation will still be true. All right. So example number 3, let's use this property of subtraction, right? The subtraction property of equality here. So I'm asked to solve 142 plus d equals 97 and then check my solution. So first I'm going to write the original equation down, which is something you'll do in your assignment. So 142 plus d equals 97. If I'm going to solve the equation, I have to isolate this variable, which means I have to zero out this value right here. So in order to zero out 142, I need to subtract 142. So I will subtract 142 from both sides of the equation to maintain my property of equality. And when I do that, these two, 142 minus 142, will zero out and leaves me with d. And 97 minus 142 leaves me with negative 45. So here, my answer is that d equals negative 35. Now I want to check it to see if it actually is true. So I'm going to take my original equation, and I'm going to substitute this value in for d here. And so I have 142 plus negative 45. Does it equal 97? And if I do the math, 142 plus negative 45 does in fact equal 97. Both sides of the equation are true, which tells me that my answer, d equals negative 45, actually works. It's actually correct. Okay, so really important that you're checking your values by substituting them back in, because it really ensures that you're on the right track. Okay, so let's look at another one. So here we're going to solve by adding or subtracting, because sometimes you could do it either way. It's up to you, right? It's whatever makes the most sense to you, because both properties work. So it says solve g plus 3/4 equals negative 1/8 in two ways. So my two ways are, well, let's use the subtraction one, because that's the one we just kind of talked about. So let's use the subtraction property of equality. So again, I'm going to write down my original equation. Okay, I'm going to go ahead, and if I'm going to use subtraction, I'm going to subtract 3/4 from both sides. So 3/4 minus 3/4 makes 0. Negative 1/8 minus 3/4. Now, if you forgot how to do that, here's how we subtract fractions, right? So in order to subtract fractions, we need common denominators. So if it's 1/8 minus 3/4, I should make them both over 8 with a denominator. So this one, I'm going to multiply the numerator and denominator by 2, which gives me 6 over 8, right? 3 times 2 is 6. 4 times 2 is 8. So then this is a much easier fractions to subtract here. Negative 1/8 minus 6/8 makes negative 7/8. And that's where this answer came from. Okay, so if you forgot how to do this, you can watch some quick instructional videos on how to add and subtract fractions. Calculators also do this really easily as well, but probably a good thing to know. So here my solution is g equals negative 7/8, right? Because this was my answer here. I zeroed this out. Negative 1/8 minus 3/4 makes negative 7/8. Now, I need to check my answer. So I'm going to go ahead and check it. Oh, not going to check my answer. I'm going to use the addition property of equality. So there I used subtraction to solve the equation, but could I have used addition? And the answer is yes. So that's what we're going to do. So let's take a look at the original equation. So instead of subtracting 3/4, I could have added -3/4. Now, some of you may ask, isn't that the same thing? And actually, it does do the same equal amount of work, right? When you subtract 3/4 or add -3/4, those exactly have the same value. So it is the same idea. It's just looking at it with two different operations. Okay. So again, I added -3/4 to each side, and +3/4 plus -3/4 makes 0. So it leaves me with just the G, and -1/8 plus -3/4, again going through adding and adding the two fractions with common denominators gives me -7/8. I should get the same answer for both problems. So whether you're adding or subtracting, as long as you're making sure to isolate the variable by zeroing out that value next to it, you should get to the same answer either way. Okay, so this just illustrates that whether you're using addition or subtraction, you will get to the same answer. Just make sure that you're looking at the signs, make sure you are zeroing out the value in order to get the variable by itself to isolate the variable, right? That's how we solve equations. All right, so example number 5, it says write and solve an equation. So it says write an equation for the problem, then solve the equation and check your solution. A number increased by 5 is equal to 42. Find the number. All right. So a number, n, increased by 5 is equal to 42. So this kind of goes back to what we did last lesson where you needed to translate a verbal expression into an algebraic expression. So here's our algebraic. So n plus 5 equals 42, right? So this is our equation that we're solving. So if I were going to solve this, I'm going to use one of my properties of equality. So again, if I'm isolating the variable, if I want to get n by itself, I want to zero out this 5. So I'm going to subtract 5 because I know that +5 minus 5 makes 0, right? So it'll leave me with n. 42 minus 5 makes 37. And so that would be my solution, n equals 37. Now the directions do say that I need to solve my equation and then check it. So I'm going to check it now. I'm going to see if 37 is going to work as my answer. So I'm going to substitute n with 37 because I say that's what the value of n is. And then 37 plus 5, does it equal 42? If you add them up, it does. And 42 equals 42. So therefore my solution does check out. So 37 is the solution for n. All right. Example number 6. Writing an equation to solve a problem. So here's a picture. Anyone recognize this? This is the Great Wall of China. So it says the first emperor of China, Qi Huangdi, ordered the building of the Great Wall of China to protect his people from nomadic tribes that attacked and looted villages. By 204 BC, this wall guarded 1,000 miles of China's border. That's a long ways. So here's our problem. In the 14th century, the part of the Great Wall of China that was built during Qi Huangdi's time was repaired, and the wall was extended. So not only did they repair this old wall, they extended it. When the wall was completed, it was 2,500 miles long. How much of the wall was added during the 1300s? Okay, so here's a little illustration. So we know they built 1,000 miles during that original era, and then they added some amount, and then we know that they finished with 2,500 miles of wall. Now, some of you might be doing the math in your head right now, and that's totally fine, but we really want to go through the process of solving the equation because that's what you're going to be asked to showcase on your assignment. Okay, so let's look at it. The original length plus additional length equals 2,500. Well, if A is the additional length that we are looking for, right, that's our unknown, that's our variable, we're going to let that be A. And so we're going to go ahead and write our equation. So the original length we know was 1,000 plus some additional length A has to equal 2,500 miles. So again, I'm going to solve this equation by subtracting 1,000 from each side because again, I'm trying to isolate this variable, right? So I got to get zeroed out, get rid of the 1,000. So I got to subtract 1,000 from both sides. So that's going to leave me with A equals 1,500. So the Great Wall of China was extended by 1,500 miles during that second era, during the 1300s. All right. So that's some guidance on how to solve equations, both using addition and subtraction. Um, Thank you for watching. Let me know if you have any questions.